Welcome to another video. If this is the first time you're watching a video on symmetric equations, then go ahead and watch it. If you've watched another video of me solving something like this, I recommend you don't continue. Get a piece of paper, solve it on your own, and come back and see if you got it right. Actually, with symmetric equations, if you get them right, you know you got them right. Okay, but if you don't know how to solve it, then just go ahead and watch it. Let's get into it. So because we're dealing with cubic sums and a cubic equation, we're going to have to explore the possibility of expanding or factoring. So if we want to factor, it means we're going to be factoring this, or we're going to be expanding x plus y, the cube of x plus y, because that's how we're going to get this. But based on what I see, I think when this is factored, we're going to have an expression in the middle that contains this. So it makes our life very easy. We're going to say that x cubed plus y cubed, the sum of two cubes is written as x plus y multiplied by x squared minus xy plus y squared. This is how you factor the bottom expression. So clearly you can see that this expression here, which is this, is 7, and they already told us that this is 35. So we can make an equation out of this and say that 35 is equal to x plus y multiplied by 7. That's 7. So that means x plus y is 35 divided by 7, which is 5. So we can say x plus y is equal to 5. Let's call this equation 1. Okay, we know that the sum of x and y is equal to 5, but we need to know what x is and what y is. We only know the sum, and we know all these crazy stuff they've given us. So what else can we do? Well, it doesn't look like we can do much, but remember, the cubic expansion of x plus y will always come into play because of this expression. We're dealing with a cubic function or cubic equation. So what we're going to do is consider this. Consider x plus y cubed. So I'm going to cube this and cube this. Remember, this is the same strategy you will use anytime you see a problem like this. You never know what you're going to be looking for until you get to it. So if I cube this and cube this, I use Pascal's triangle expansion for this, what would you get here? Well, I know that the first coefficient will be 1 and the first power will be cubed. So it's going to be x cubed. And the second one is going to be plus 3x squared. I reduce this power by 1 and then I introduce y. 3x squared y plus the third coefficient is still going to be a 3 from Pascal's triangle. And then I'm going to reduce this power by 1 and increase this power by 1. So it's going to be y squared. And I reduce this by 1 again, which makes it 0. And the coefficient is 1, so it's y cubed. And that's it. This is the cubic expansion of x plus y. And 5 cubed is going to be 125. So how does this help me? Well, it helps me a lot because I know that x cubed plus y cubed can be written together. And in the middle, it looks a bit messed up, but you can clean it up. Factor out whatever is common. So I know 3xy is here, 3xy is also here. So at the end of the day, I have 3xy, x plus y. That's what the middle part becomes, and I still have 125. Now some things are very obvious. X cubed plus y cubed was given in the original problem, so this is 35 plus. We were told that x squared minus xy plus y squared. Oh, we don't have that here. Ooh. 2, but we've got this. X plus y is equal to 5. So I'm going to go here and write this as 3 times xy times 5 equals 125. Did you see that? Okay, so if we try to isolate this, you'll end up with, if you subtract 35, move 35 to the other side, you end up with 90. And if you multiply 3 by 5, you get 15. If you divide 90 by 15, okay, you're going to end up with xy equals 6. That's what you're going to get. Okay, so we know that xy will be equal to, let's just write it, 125 minus 35 divided by 3 times 5, 15. Well, your answer is 90 over 15, which is equal to 6. So xy equals 6, x plus y equals 5. So watch this. X plus y equals 5, equation 1. Xy equals 6, equation 2. So even mentally, you can know the answer to this. Think of two numbers. If you add them together, you're going to get 5. If you multiply them together, you're going to get 6. Yeah, the numbers are 2 and 3, or 3 and 2. You just switch it. Well, you always have that happen whenever you deal with symmetric equations. So look at this. So you can solve this just mentally, or you can solve it using simultaneous equation by substitution. Okay? So, but we know our answers are 2 and 3, or 3 and 2. You can flip it. So let's just finish this up in case somebody says, how did you know it's going to be 2 and 3? Well, let's see. From here, I can say y is 5 minus x. Okay? Let y be equal to 5 minus x. From the first equation, I can go plug in 5 minus x into the second equation. So I have, so x times y will be x times 5 minus x, which is equal to 6. So I have 5x minus x squared equals 6. And if I rearrange everything, I'm going to end up with x squared minus 5x plus 6 is equal to 0. And we come back to the same question I asked when you solve this mentally. How would you factor this? We know by factoring, what do we have? We have x minus 2 times x minus 3 will be equal to 0. That's the factored form of this popular quadratic equation. And we have x equals 2 or x equals 3. And whenever x equals 2, y is going to be 5 minus 2, which is 3. So we have the set of solutions will be equal to, when x is 2, y is going to be 5 minus 2, which is 3. Or, when x equals 3, y is going to be 5 minus 3, which is 2. So it's going to be 3, 2. Never stop learning. Those who stop learning, stop living. Bye-bye.